Hey guys, this is CHEMPLIFIED and today we will talk about oxidation number. Oxidation number is one of the simplest topics in chemistry, but it is also a widely used topic. So we will talk about the definition and the rules that you must follow to find out oxidation number. The rules are really simple and we will learn them one by one. First of all, we will go for the definition. The definition of oxidation number is oxidation number of an element in any species is equal to the charge which its atoms appears to have acquired when all other atoms in the species are removed as ions. So what is the definition saying? First of all, the term that is useful for you is appears. It means oxidation number is not fixed. It varies from species to species, right? And second thing is ions, removed as ions. What it means is, for example, in case of H2SO4, you need to find the oxidation state of sulfur. So what you will do is, you will take out oxygen and you will take out hydrogen as ions. After that, after taking these out as ions, the remaining charge that is present on sulfur will be equal to the oxidation state of sulfur, right? This is the meaning of removing as ions, right? So let's repeat the definition. Oxidation number of an element in any species. By species it means molecule, polyatomic ions or simply ions, right, is equal to the charge which its atoms appears to have acquired when all other atoms in the species are removed as ions. This is one of the definition. This is one of the definition of oxidation number. There are the other definitions also, right? Now we will talk about the rules that you must follow to find the oxidation number. Rule number 1, in elements in free or uncombined state, in elements in free or uncombined state, each atom bears an oxidation number of 0. For example, we can take noble gases, helium, neon, argon. All these will have oxidation state equal to 0. Any other atom or element that can exist in free state, right, will also show oxidation state equal to 0. This is the meaning of the first rule. Now there is one more thing that you should remember before moving up. Electronegativity. Definition of electronegativity is the ability to attract the shared pair of electron towards itself. So in one way or another, electronegativity will be used as a concept to find oxidation number. Now when we were talking about this H2SO4 and we were talking that hydrogen and oxygen will be removed as ions. So when they are removed as ions, they will either take up electron and then leave, or they will lose electron and then leave, right? This will happen. So this will happen on the basis of electronegativity. You can use electronegativity. For example, hydrogen is with low electronegativity, so it will lose electron towards sulfur. Oxygen has high electronegativity, so it will take electron from sulfur and then leave, right? That's how you can use the concept of electronegativity in oxidation number. So first rule is done. Now we will move to the second rule. For ions composed of only one atom, now we are talking about ions. For ions composed of only one atom, the oxidation number is equal to the charge on the ion. Examples, learn by examples. Na plus, right? Ca2 plus, Cl minus, these all are ions. Now charge is +1, so oxidation state will be +1 for sodium. In this case charge is +2, So oxidation state for calcium will be +2. In this case, charge is -1. So oxidation state will be -1, and that's how you can use it. In KMnO4, manganese will have +7 charge. So oxidation state will be +7. That's how it goes. In compounds, now this is general that you should remember. In compounds, all alkali metals have oxidation number +1. We are talking about alkali metals. Alkali metals means group 1. Group 1 atoms will show +1 oxidation state, including hydrogen. Hydrogen will also show +1 oxidation state in most of the cases. We will talk about the exceptions later in the same video. All the alkaline earth metals have oxidation number of +2. We are talking about group 2. Group 2 will show +2 oxidation state. You can go by this one also. Group 1 means +1 oxidation state. Group 2 means +2 oxidation state. That's it. Aluminium. This is the third one. Aluminium is regarded to have an oxidation number of +3 in all its compounds. In all compounds, aluminium will show +3 oxidation state. We are talking about only aluminium, right? Aluminium is which group? Aluminium is group 13. Aluminium is group 13. But in group 13, we are talking only about aluminium and not any other element, right? So remember these three particular rules. Now we will talk about oxygen. Oxygen is widely used in making compounds. You will find oxygen in one place or another. So oxidation number of oxygen in most of the compound is -2. Here there is a term most. Most of the compound means that there are some compounds where oxidation number of oxygen is not -2. In general it will be -2, but there will be some cases where oxidation number of oxygen will not be equal to -2. Let's see those exceptions. Exception case 1 means there are more than one case. Peroxides and superoxides. In case of peroxides, that is H2O2 and Ne2O2, these are the examples of peroxide. Each oxygen atom is assigned an oxidation number of -1. In general, oxidation state is -2, but in case of peroxide it will be -1. In case of superoxide examples are KO2, RbO2, rubidium. Each oxygen atom is assigned an oxidation number of -1/2. Now this is also a different thing. Oxidation number in fraction. In this case, the oxidation number of oxygen in fraction. This is known as paradox. We will talk about it in the coming videos, right? But for now, just remember the rules. In case of peroxide, oxygen will show +1 oxidation state. In case of superoxide, oxygen will show -1/2 oxidation state, right? Case 2. What is case 2? When oxygen is bonded to fluorine. Now the concept of electronegativity will come into play. Fluorine is most electronegative. Right? Now when fluorine is combined with oxygen, the oxidation state of oxygen will become +2. Remember this. Why this is becoming +2? Here this is your oxygen, this is your fluorine. Now we know that fluorine is most electronegative. Most electronegative means it will take the shared pair of electron towards itself. So oxygen will have to leave as positive ion. Right? Oxygen will have to leave as positive ion, and when oxygen leave, it will have a charge of +2 because it will donate 2 electrons to the 2 fluorine atoms. That's why oxygen will have a positive oxidation state when it is combined with fluorine. Remember, only with fluorine oxygen will give you positive oxidation state. Otherwise, the oxidation state of oxygen will always be negative. It can be it can be -2, -1 or -1 by 2, but it will be negative. In all the three cases, the oxidation state is negative. But only in case of fluorine, the oxidation state of oxygen will be positive. Remember this. Oxygen difluoride, these are the two examples of oxygen and fluorine compounds. Now let's move to the next. Oxidation number of hydrogen is +1. Now there is another term, except, means there are exceptions. Oxidation number of hydrogen is +1. We have already discussed oxygen is in group 1 in the periodic table, right? It can be placed in group 17 also with similar properties but don't think about that. Just think of it as group 1. Oxidation state of hydrogen is +1 in general because it is in group 1. We have already discussed that. Except when it is bonded to metals in binary compounds. What kind of metals are we talking about? If you look closely, this is lithium, sodium, calcium. Group 1 and 2, and this is aluminium, group 13. In this case, we already know that aluminium will have +3 oxidation state, right? After solving this also, you will find +3 oxidation state. But you know that when hydrogen is combined with group 1 and group 2 elements, it will show negative oxidation state. Remember this one. In this case, lithium hydride, the hydrogen will have a -1 oxidation state, -1 oxidation state, -1 into 2 oxidation state. Why? Because there are two hydrogens. So when hydrogen is combined with group 1 or group 2 elements, it will show negative oxidation state, right? Remember this one. This is also an important rule. Now again we will talk about fluorine and other halogens. In all its compound, this is surety, in all its compounds, fluorine has an oxidation number of -1. No exceptions. Fluorine will always show -1 oxidation state. That's it. Other halogen, however, other halogens other than fluorine, that is chlorine, bromine, iodine, also have oxidation number of -1 in general. But oxidation number of -1 when they occur as halide ion in their compounds. In general, oxidation state of chlorine, bromine and iodine will also have -1 oxidation state. But when chlorine, bromine, iodine are combined with oxygen, as in oxo acid, will show positive oxidation state. Why? Let's take an example, simple example. Cl2O, in this case, oxygen is more electronegative and chlorine is, in comparison to oxygen, less electronegative, which means the shared pair of electron will be transferred towards oxygen and chlorine will have to leave as positive ion. Remember this? That's why in oxo acids of halogens, the halogens will have a positive oxidation state. Also, let's take another example, IF7. This is also, iodine is also halogen, fluorine is also halogen. In this case, iodine will leave as positive ion. Why? Because fluorine is more electronegative than iodine, it will take the shared pair of electron towards itself, and iodine have to leave as positive ion. Remember this, right? I think I am very much clear with this. Now let's move to the next. This is the last rule. The algebraic sum of oxidation number of all the atoms in a compound must be equal to 0. What does it mean? Let's suppose oxidation number of potassium is X, manganese is Y, and oxygen is Z. We have found that oxidation number of potassium, magnesium and oxygen are X, Y, Z. So when you add X plus Y plus Z, you will get 0 as an answer, right? We will solve this particular example. We know that potassium is group 1, so the oxidation state is taken as +1. Plus, we don't know the oxidation state of manganese, so either I can take X or I can take manganese as it is. Plus, we know that oxidation number of oxygen is taken as -2 in general. There is no chlorine, there is no fluorine, there is no fluorine in this particular molecule, so oxidation number of oxygen will be -2. How many oxygen atoms are there? 4. So you will have to multiply it with 4. And the algebraic sum, this is the algebraic sum, and this must be equal to 0, right? Now solve it. You will get oxidation state of manganese as +7. So oxidation number of manganese is +7, and when you add the oxidation number of potassium, that is +1, and oxygen is -2 into 4. When you add these three values, you will get 0. The algebraic sum is 0, right? Now this is the second example. Try to solve it yourself. Potassium has an oxidation state +1, oxygen -2, chromium, take it as X, and find the answer. Now remember, there are 2 chromium atoms, so you will take 2X. There are 2 potassium atoms, you will multiply it with 2. There are 7 oxygen atoms, you will multiply it with 7. And then solve it, equate these to 0, and then find the value of X. This is the method to calculate oxidation number. We will use this method in the next video to take on many different examples. Remember, these all are the important rules that you need to follow to find the oxidation state of any element in the molecule. In this case, we are finding for manganese and chromium. We will also talk about paradox oxidation number, where the oxidation number will be in fraction. When you solve using this formula, you will find that the oxidation number is in fraction, right? We will talk about that also in the coming videos. So this will be it for today's video. Thank you very much.